Hello and welcome to Chapter 4, Section 3, the transfer of energy. Now we've been talking about the difference between heat and temperature and things like that. Also how different kinds of energy transfer. But heat specifically moves from object to object in 3 different ways, and that's the only thing this section is about. So I need you to learn the 3 ways that heat move and be able to tell the difference between them. So energy moves its heat in 3 ways. The first one is called conduction, and this is direct contact between objects. When 2 objects touch, if this one's hot and it touches that one, then this one gets hot. Direct contact. Essentially what's happening on a molecular level is that the kinetic energy in the warmer object is transferred to the cooler object when they touch. So you've got all of this energy that gets from one right to the next one, and it has a direct line of transfer. Now, you've heard the term conductors. These are objects that transfer kinetic energy well. These are like metals, which is why when you're working at a stove and you're stirring something in a boiling pot of water, a metal spoon will heat up really quickly, but a wooden spoon or a plastic spoon won't. Metal's a good conductor, wood and plastic are not. They're called insulators. Conductors have a low specific heat because it doesn't take a lot of temperature to raise the whole thing up 1 degree Celsius. Insulators have very high specific heat. It takes a lot of energy to heat them up because they don't conduct energy well. They are very poor conductors. These items are used to keep the kinetic energy of some objects at a constant. Styrofoam cups. Styrofoam has a very high specific heat. It's an insulator, which means the hot that's inside the cup doesn't transfer to your fingers on the outside of the cup. It's an insulator. Okay, that's conduction. The second way that heat moves is through convection, and this is energy transferred through the movement of gases or fluids. Gases or liquids. So this is the do you remember 6th grade when we did the whole the mantle, the hot spot in the mantle, and the magma is hot at the bottom and it rises up and it does this whole liquid transfer thing. Warm liquid rises, cool liquid sinks, and then it mixes up. Because warm liquid or gas is lighter than cooler, because cooler gases and liquids are closer together. Warmer is farther apart because it's got more energy, so there's more space in between the particles, so it's lighter weight. Cooler molecules are closer together, which makes them denser, which makes them heavier. Cool, heavy liquids sink to the bottom, warm, lighter stuff floats to the top, and this is how liquids and gases get mixed up. Now this is convection. So conduction is touching solid object to solid object. Convection is mixing liquids or gases. Okay, and the way that I remember to tell them the difference, conduction is, picture a really hot day at the beach. You ever had such a hot day at the beach that when you walked on the sand it actually burned your little feet? Well, picture how a duck feels. Duck walking along the beach going ow, 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 because his feet are touching the sand. That's ducks touching the hot sand, so that's conduction. You got to touch it. Does that make sense? It's the way I remember. So, all right. Then there's a third way, and that's radiation. And this is energy that travels as electromagnetic waves. Now, you don't actually need solid, liquid, or gas for this. This can travel through empty space, and this is actually how the energy gets from the sun to any planet, but us, planet Earth, it gets to us through empty space as electromagnetic waves, and it doesn't start turning into heat until it touches a particle, gives it that extra electromagnetic energy, and that makes it vibrate faster, which makes it hot. So there isn't actually heat coming from the sun. It's electromagnetic waves that end up making heat. Kind of cool. Now, it's not just the sunlight that is electromagnetic waves. Visible light is electromagnetic, microwaves, infrared light, x-rays, all of this stuff on the light spectrum. All of those different kinds of waves all are radiation, and that's energy traveling as electromagnetic waves, and it can happen through empty space. So, ta-da! That was all three. I need you to know these. These are important, and we're actually going to come back to these a couple of times. So learn them, learn the definitions, learn how to tell them apart, because the next thing that you have coming up is a test. So we did chapters 3 and 4. At the beginning of chapter 3 in the class, we learned the 6 different forms of energy: thermal energy and nuclear energy and all of those. 3-2, that's when we talked about how the law of conservation of energy, how energy is never lost, it just changes forms. Note that my shorthand for energy is E, so make up your own shorthand if you want. We also knew the difference between kinetic versus potential energy in section 2. Section 3, we talked about energy efficiency and how energy can change different forms. It never goes away, but it could change into different kinds of energy. Then we started chapter 4. Section 1 was all about temperature and particle movement. Section 2, how energy flows from a warmer area to a cooler area, and the difference between thermal energy and heat, the difference between a calorie and a joule, even though they're both measurements, and what specific heat is, especially if you own an orange soda lake. And then section 3, this was it. How is energy transferred? The 3 different ways. So good luck to you. Hope that the test goes well for you. Please, please, please study. Go over your notes. Go over the important things. Make sure that you can answer questions about these topics. Okay? Good luck and take care, and I will see you tomorrow.